Welcome to OpenSearchCon 2024. It's great to see so many familiar faces, and I'm so glad that so many of you could join us for our first time in San Francisco. For those of you who don't know me, my name is Eli Fisher, and I oversee the product management team working on the OpenSearch project. This year has been a year like no other. We are super excited to be joining the Linux Foundation and for the future of working together with such a great organization. We'll talk a little bit more about that in a little bit. What I'm really excited to talk to you about is just the trajectory of this project, not only looking at the massive progress that we've made in the rearview mirror, but also at the incredible potential that we have for the future of OpenSearch. Now let's go all the way back just for a minute. When we first introduced OpenSearch in April 2021, we weren't sure what the growth trajectory of the project was going to look like. We were all surprised when we found ourselves managing a one-of-a-kind popular project with a vibrant community. Back then, we were practically the only completely open source search and analytics engine that was out there. The popularity was self-evident, and it happened really quickly because of all of our commitment to make OpenSearch a success. One of my favorite quotes from the original announcement introducing OpenSearch highlights this right in the first paragraph. We are making a long-term investment in OpenSearch to ensure users continue to have a secure, high-quality, fully open-source search and analytics suite with a rich roadmap of new and innovative functionality. We meant it then, and we are happy to have lived up to this vision, and it remains as true today as ever. So, what did it take to get from our first announcement to delivering on the many innovations you're all familiar with? After we announced OpenSearch was being created in early April, we needed to focus on getting our first release of the software out there. Getting there by July was exciting and a lot of hard work, and it included dealing with a lot of errors like these. The complexity and the size of the fork was quite large. Over 650 pull requests were merged, 56,000 or so files needed to be modified, and 4.5 million lines of code needed to be deleted in order to get the development operations up and running. 4 months later, we had a feature-complete version of the software, and we launched. The first year was really all about the fundamentals. Operationally, the environment felt very much like a Silicon Valley startup. We had to go from nothing to something to anything. Destinations and processes needed to be built and cared for, like the GitHub repos, the project website, and the build and release processes that we eventually automated. We also needed governance. Governance for contributors, committers, maintainers, and the like, so that anyone could participate in the project. On the technical front, there wasn't enough support for a number of important language clients, and for some languages, there was no support at all. On top of that, we also needed to support a variety of distributions with easy installs so that you could use OpenSearch on your operating system of choice. Across this pyramid, there was a ton that needed built. And thankfully, the community stepped up and helped us build these fundamentals. This was a positive sign. There were a number of people and organizations who were all in and determined to make OpenSearch a success. All right, so we were up and running. We had a pretty good plan. We had a roadmap looking into 2022. We had just released 1.2, and then Log4j. Like many projects, OpenSearch was affected. I mean, after all, this was a major event across our industry. Now, thankfully, the community rallied and got to work quickly. Throughout December, all of the issues were remediated with a rapid series of 4 releases in 45 days. All of this work set the stage for a massive wave of innovation in OpenSearch in the ensuing 18 months. As 2022 began, we put Lucene 9 on the roadmap and OpenSearch 2.0, and we knew that there would be breaking changes, so we gathered a lot of community input so that we could figure out where those changes were and how we could minimize that impact. After 2.0 launched, performance, stability, and feature innovations started rolling in at a rapid pace, and that has continued to this day. Just to mention some of the big ones in each category. So for search, we've integrated the latest AI and vector database capabilities, including built-in neural search with multimodal support. We've introduced hybrid text and vector search so that you can combine multiple different search techniques when building search applications. We've also enhanced search pipelines so that you can support complex search flows like result re-ranking. In the GenAI space, we've made it easy to build generative AI applications while using OpenSearch as your vector database. This includes adding conversational search support for RAG applications. We added vector quantization to compress the amount of memory that was needed to be used and thus save costs. And we launched the OpenSearch Assistant Toolkit, which allows you to build GenAI experiences inside of OpenSearch dashboards. For observability and security use cases, we've expanded OpenSearch's core log analytics capabilities to simplify gaining insights across your operational data. Prometheus is now integrated so that you can pull in metrics alongside your logs and traces. We've enabled query federation through Spark so that you can use OpenSearch analytics across your data in your data lake. We've also delivered out-of-the-box threat detection rules so that you can quickly identify security events. And we added built-in correlations so that you can understand the relationships in your data throughout these events. OpenSearch dashboards also got streamlined to support simplified daily use for just about anyone. We decoupled OpenSearch dashboards from the OpenSearch backend so that you could connect to multiple OpenSearch backends, enabling centralized views of all of your data from a single endpoint. We also overhauled the entire user experience of OpenSearch dashboards to simplify the experience. During this rapid period of innovation, there were also several significant contributions by project partners. And just to name a few examples, Intel introduced Z-standard compression to reduce the storage footprint of OpenSearch clusters and thus costs. Aaron contributed built-in RAG-based processors and conversational search to make it easier to build RAG-based GenAI applications. And Ivan created and contributed concurrent segment search, which is used to accelerate performance for large search workflows. The innovations in OpenSearch have allowed the community to build amazing new products and experiences. One example of this is highlighted by what Adobe is doing with OpenSearch. They've been using OpenSearch to enhance their existing products with generative AI experiences. And I'm super excited to bring Anupam Chaturvedi to the stage to dive deeper into this example. Thank you.
Hi, good morning, everyone. So I'm Anupam Chaturvedi, and I'm engineering manager of Acrobat GenAI services team in Adobe, and I'm here to take you to the journey of how we are using OpenSearch to build our robust and next generation AI capabilities. So let's get started. So I'm confident that each one of you must have interacted with PDF at some point of time. right? But the interaction for the last decades, right, the PDF has been a very dominant file format, and the interaction has been very static in nature, right? A normal use case involves going through the PDF word by word, line by line, or maybe searching for some content in the PDF, right? But using the GenAI assistant, we have reimagined the way a user interacts with the PDF. So now you can ask the GenAI assistant to summarize the PDF for you, and even you can ask questions to the PDF, and the GenAI assistant will give you the answers along with the attributions. Now let's quickly see the demo of attributions live in action.
I have the employee handbook open in Adobe Acrobat, but it's over 20 pages long. It can take a lot of time to find the right information, summarize it, and write an email. With the help of the new AI assistant in Acrobat, I can get that done in a fraction of the time. AI assistant gives me an overview, suggested questions, and a prompt to ask my own questions about this document. I'm going to ask AI assistant a question about the time off policy. It responds with the policy based on the document. I can even click on references to learn more and check accuracy.
Okay, so now let's pause a bit and understand the importance of attributions, right? So LLMs have been very powerful in analyzing the content. But there's a problem, the problem of hallucination, right? It has not been solved completely. So whenever a user is seeing these answers, they are not confident whether the answers are indeed coming from the document or it's something LLM is making up, right? So here the attribution comes into picture. Attribution provide the confidence to the users that the answers are indeed coming from the document, and as an added bonus, the user can go ahead and cross-verify the answers as well. So now, since we have attributions clear, now let me quickly explain how this end-to-end pipeline works. So our first workflow is the ingestion workflow, as a result of which we are making the document ready for asking the content questions, right? So PDF is a very binary file format, right? So you cannot directly feed it into LLM. So we have to do some massaging before we send it to LLMs, right? So what we do, as can be seen in the box 1, we send it to our extract service. This extract service takes PDF as an input and emits the JSON. So this extract service not just used in these workflows, it is also available externally to be used by other customers as well. So now we have the JSON, right? Now, in certain cases, when the PDF is very large in size, we have to do the chunking as well, right? So as you can see, in the step 2, we are parsing the JSON and splitting it into smaller chunks. So once the entire JSON is prepared, then as can be seen in the step D, we are sending this JSON to the embedding service, and then we are storing these embeddings into OpenSearch cluster, as can be seen in the step E. Right? So now you have the PDF ready, you have the content ready, you're storing it in the OpenSearch, and then as the final step of the ingestion workflow, we send this session info to the client, which will then be used in the next step to fetch the content from the PDF. Okay, so my ingestion workflow is completed, my PDF ready to be asked questions. Now let's see the second phase. This is the phase when the user started asking questions, right? So in the step 1, when the user asks the questions, we send a call to the embedding service to generate embedding for our questions. In the step 2, as I was mentioning in the ingestion workflow, we retrieve the content from the session information using OpenSearch, right? Now, after step 2, I have the content, I have the questions. Now let's go to LLM to get the answers. So in the step 3, we reach out to LLM with the document content and with the questions, and then we get the answers. So now let's see how we are doing with the attributions, right? So in the step 4, let me take you the step-by-step process, right? In the step 4, as you can see in the arrow A, we are sending these answers to the embedding service to generate embeddings for our answers. Now you have the answers to the embedding. Now in the step B, what we are trying to do, we are figuring out the sections of the document which has references to these answers, right? So for that, we are querying the OpenSearch, we are figuring out the sections of the document which are related to these answers. And when this entire process of step A and B is completed, we have the answers with the attributions, which we send it back to the clients, as you can see in the step 5. So this is our end-to-end pipeline. This looks pretty straightforward, right? So it took a lot of experimentation and a lot of iterations to reach to a state, so not that straight. So now let's take a look at what kind of skill and functional requirements that we had, right? So Acrobat is one of the largest products of Adobe. It's processing millions of PDFs every day. So we have to build a solution that scales for 100 million plus PDFs per day in the starting, which will probably increase to like 500 million plus PDFs in the near future, right? And then we have to ensure our entire experience is seamless in nature, right? So the idea was the indexing latency should be less than a second. In terms of the requests per minute, our target was to process more than 1,000 documents per minute in the beginning, right? And of course, the solutions needed to be cost effective, right? So with this huge responsibility on our shoulders, we start exploring options. So as I was mentioning earlier, we explored multiple products, right? And then we ended up on the OpenSearch because it ticks all the right boxes at all the right places, right? So we are using OpenSearch to find the sections which are closest to our answers by using KNN algorithm combined with the cosine similarity. So in the beginning, we have to do multiple experimentations, right? We have to try with the multiple matching algorithms, multiple embedding service. So here, OpenSearch helped us a lot. So OpenSearch supports multiple different embeddings and multiple experimentations, because of which our experimental speed was rapid fast. And then with respect to the throughput, OpenSearch scales very nicely for high throughput use cases. Now, with OpenSearch in mind, we started our journey. OK, now let's understand how we are using OpenSearch. So a typical usage of OpenSearch involves bulk indexing a document, storing it for some time, and then querying it a bit later, right? But our use case was a bit different. We have to ensure the document content is indexed on the fly. And at the same time, we have to ensure our querying should be near real-time in nature. So this real-time indexing combined with the near real-time querying yields some great results, which is powering attributions in Acrobat GenAI Assistant today. One more thing, right? So a lot of enterprise customers uses Acrobat, and they do not want their content to be stored for a longer duration of time, right? So we have to ensure that the content needs to be transient in nature and stored very temporarily. So OpenSearch also provides a very useful feature, which is rolling index. This helps us in having validity on the indexes, and as well as at the same time, we can refresh the indexes as well, right? So we went ahead and started using rolling index. So each time the document is opened, a separate index is created and maintained. And Acrobat GenAI has a policy to get a new index every hour, right? And as I was mentioning regarding the validity of the indices, our index has a lifespan of 12 hours. So this does not ensure the transient nature of the content, the refresh nature of the content, but OpenSearch also helps us to migrate to new index in case there is any updates that we are doing to the internal service, right? For example, if we are changing the embedding service, it was very easy for us to migrate to the new index without any downtime, something that we did a bit of time back. So to summarize, unlike other vector DB use cases of storing a knowledge base, our use cases required us to churn the data at very regular intervals, right? We have to ensure our end-to-end cycle of indexing the content, querying the content, and then keeping that content transient in nature should be very seamless. So here, our hourly rolling index policies ensure that the data freshness by purging any content which is 12 hours old every hour. And this not only ensures the freshness of the data, but as a cherry on the top, it also helps us meet our security requirements. So that's most of it, how we are using OpenSearch. Then, of course, numbers, right? How we are doing it. So let's see at the numbers, right? So with respect to the index embeddings, we are indexing about 20 million embeddings during our peak hours. And as I was mentioning, we have a lifespan of 12 hours for indices, so we have 13 indices that is live at any point of time. And for our algorithm, we need to support two kinds of indices, one for the short tokens and another for the long tokens. So we have 26 indices. So now let's take a look at the shards. So currently, we are configured with 18 shards per index. And as I was mentioning, we have 26 indices. So 26 into 18, we have 468 primary and 468 replica shards. So we have total 936 shards configured. Now, let's take a quick look at the memory utilization. Each embedding is taking 54 KB of space. So on peak hours, our total memory usage is around 1 TB, right? Now, let's see how we are doing with respect to latency. So as you can see, as I was talking about earlier, so we set a target of 1 second for our indexing and queuing latency. So as you can see, we are able to beat that target, right? So our indexing latency is just 0.855 seconds per document per embedding. And our searching latency is even less than that, just 0.4 seconds. So these numbers are telling a true picture. Our entire journey has been made seamless thanks to OpenSearch. And with respect to peak throughput, we are having 3650 embeddings per second. So as it can be clearly seen in this slide, we are able to handle a high amount of load, and then we are able to provide a seamless journey to our client, again, thanks to OpenSearch. So with that, this will be the end of our presentation. But so the GenAI assistant was launched pretty recently, right? So in this short duration of time, we have added a lot of features, right? Support of multiple documents, meeting transcript, chat history, and many more. And we have also recently introduced the support of English and French language and the streaming experience. So I will request each one of you to try and use GenAI Assistant in Acrobat and reimagine the way you interact with the PDF. With that, I would request Eli to be back on stage.
That was awesome. All right. Thanks for that wonderful example of using OpenSearch to innovate, Anupam. This is the type of community we have in the participation levels we've been so thankfully used to from the beginning. Consultancies, software vendors, SaaS providers, and open source enthusiasts have all joined with the project to create new capabilities and features and support each other. The groundswell of user activities has never stopped growing. As a matter of fact, today, we have more contributions from outside of AWS than ever before, both by volume and by percentage. We've come to expect this after several years of sustained community growth. If you look at this from a numbers perspective, you can see that we have dozens of maintainers, hundreds of code and content contributors, and thousands of members of the forum and the Slack that don't work for AWS. We're all here for the same reason, to build a great product together. OpenSearch has seen astounding growth over the last few years. Since the project's earliest days, we've always viewed it as a community-driven initiative where a wide variety of people and organizations could freely contribute. We continuously looked for ways to increase the transparency of how the project operates, And we even supported more open governance when we opened up the project maintainers to outside of AWS in 2022. As we look toward its future, creating a vendor-neutral foundation was the next logical step to ensuring it could thrive as an independent project. You may have heard from last week's announcement, OpenSearch hit a major milestone and joined the Linux Foundation. You can all clap. This is a big one. Yeah. Joining the Linux Foundation will make it easier for a wider variety of companies and organizations to get involved in the community and invest in its future success, while at the same time allowing this community to tap into the extensive resources and experiences that the Linux Foundation has to offer. To the community who has been so great all along, you have created the conditions for us to take this step, and I want to thank you all very much. Now, really, though, what I'd like to do is get a fresh perspective on this from another guest. To talk about how OpenSearch fits in with the vision of the Linux Foundation, I'm super happy to introduce Jim Zemlin, the Executive Director of the Linux Foundation, to the stage. Let's all give Jim a warm welcome. Awesome.
Thank you. Thank you. We are so happy to have OpenSearch as a part of the Linux Foundation. And it was so impressive to see how Adobe is using OpenSearch and tools that all of us use every day. I did notice that Adobe is also using Redis. And I would like to suggest Valky, that you take a look at that as well. Could be good. Pay attention to the rest of my presentation as to why I may be recommending this. But one of the things that I thought was funny in the intro video today was one of the folks mentioned, we released this thing and it's free, and now we kind of had to figure out how to make money on open source. And this is my 20th anniversary at the Linux Foundation. Linus and I have been working together for that long at the foundation. And I've gotten the same question for 20 years, right? How do you make money on open source? And oh my God, there's a crisis in open source. Companies are going to go bankrupt because they are based on or use or do anything related to open source. I mean, I just sort of perennially hear this. And so a few years ago, the Linux Foundation, working with Harvard Business School, went to answer the question, what is the value of open source, and are people making money off of this? And when we did this, one of the first things we realized is open source today represents about 90% of the code in any modern technology, product, or service. I mean, you just saw, I am sure that underneath all the other technology in Adobe's products, there is Linux and a host of other open source infrastructure that's being used. And that's the same in an Android phone or any of the hyperscale cloud computing platforms, really any modern technology product and service. So clearly, somebody's doing well using open source, distributing open source, and so forth. And let me just give you a sense in aggregate what we found with Harvard about just how much money, how much value is churning through this. Remember, open source isn't necessarily a business model, it's a production model for software. That's what you all participate in as developers and maintainers of OpenSearch. You're working together to create software. And then organizations use that to, enable the technology you just saw from Adobe, or to offer products on Amazon Web Services, or a whole host of other applications. The Linux Foundation actually is a user of OpenSearch as well, and you will be using it to look at developer analytics, how your community is doing on our LFX platform, which presents visualizations of community growth and so forth. And the value of all this stuff is astounding. The supply side value, what it would take to rewrite all this stuff, if you just had to start from scratch, this is the production value, is over $4 billion. And that is an amazing number in itself. But it's the demand side value that I think is so intriguing here. If the world had to go sort of purchase on the market all of the software that we take for granted, all these open source building blocks that are used to create all of our technology, the collective cost would be over almost $9 trillion. I mean, that is an eye-popping number, even for Silicon Valley, where we're seeing trillion-dollar valuations of some of the largest companies on Earth. This eclipses even that. It's just an unbelievable amount of value. And in 2024, I think what's really interesting is to look at, now that open source is a fundamental building block, what do people want to see in an open source project that they're betting on? Remember, technology is an implicit futures contract, right? You know, if I pick the wrong database, if I, as a developer, picked the wrong programming language, you know, I might have picked a language that's defunct now. I have an old Palm Pilot that I really invested in, and now it doesn't do anything for me. I mean, you get the gist. You have to ask, like, will this be here? Will it be accessible to me? And will I be able to use that technology under the terms that I agreed to initially? And that's the important thing about what's happening in terms of bringing OpenSearch to a neutral nonprofit like the Linux Foundation. At the Linux Foundation, our goal is to become the greatest shared technology investment in the world. We want to be the place where the most important software, the most valuable software gets co-created by hundreds of thousands of developers, and that, for all of the over 400 people that work at the Linux Foundation, is going to be our mark on society. And we're going to do that with OpenSearch as well, by making sure that people can use and co-produce this software with intention. That everyone who participates in this community can share what they want to share and keep what they want to keep. By making sure that our organization, which has no profit motivation, is collectively owned, has a 20-year history of neutrality in projects like Linux, Kubernetes, definitional open source projects, provides certainty. Certainty that the license will not change. Certainty that decisions will be made collectively. Certainty that there is an open governance so that we can work collaboratively in the most productive and transparent way. And then support for the community. And this is kind of what I think is a little less understood about the role of a foundation than other things, which is obviously the Linux Foundation doesn't shoulder a $4 billion payroll. Engineers who work for professional organizations whose companies are paying them to work in open source are the biggest source of investment. Like the Linux Foundation's annual operating budget is a tiny drop, but it's an important drop because we're sort of the supporting cast. We maintain the neutrality of the IP, we help provide development infrastructure, we convene events like this so developers can get together and make decisions. We make sure that the project has access to the best cybersecurity practices so that we can deal with modern application security and have an application security supply chain that has integrity. That we can work with key maintainers to make sure that they have support. You know, last Friday I flew to Vienna for 24 hours to sit down with the key Linux kernel developers. Every year the Linus and the core maintainers of Linux get together for their kernel summit. And it may surprise you that there's about 130 individuals who really make the decision on the vast majority of Linux. You know, you always think of Linux as this huge long tail of hundreds of thousands of developers who work on it, and they do. People keep making new hardware, new drivers need to get created, there's a lot of software development going on. But at the top of that long tail is a small head of really critical maintainers who need support. Same in OpenSearch. And so one of the things we do is we make sure that if a maintainer is getting an inhuman amount of pull requests, is being overwhelmed, or maybe they're working outside of normal working hours, we proactively will go to them and say, hey, can we get some help? And that help comes from a lot of other places. It comes from the community. And with OpenSearch as a part of the Linux Foundation, we are going to harness our knowledge of how to bring community forces to bear to help core maintainers, to build a larger community, to enhance this platform, to make it more secure. And that's going to come from the sponsors and supporters or anyone else in the form of all of those good things. You know, by having Amazon, Uber, SAP, all of the companies you see here providing support, not only through resources to help the foundation support the project, but most importantly, actual engineers that they pay to work on the project, we are going to see OpenSearch get even better, even faster, right? Because now these companies have certainty. They have a neutral place. They can say, you know what, now we'll assign 10 engineers to this full-time to work on this project and do it without any hesitation. And how do I know this works so well? Well, obviously Linux is now the sort of platform that we all depend upon. But more recently, there's an interesting one, PyTorch. This is another Linux Foundation project. So we took over the PyTorch product similar in the way that is happening in OpenSearch. Meta decided, you know what, in order to grow our community, we're going to put PyTorch into a neutral foundation at the Linux Foundation. And that will enable more developers, more organizations to bet on this technology, provide the certainty that we need to invest. And since that has happened, the adoption of PyTorch has skyrocketed. Now, I think a lot of that is because PyTorch is just really good technology, but I do have to give a little credit to the neutrality because maybe correlation or causation here, now PyTorch has literally become the dominant platform in AI, and TensorFlow, which is still a single company-owned project, has diminished relative to PyTorch. This stuff works. And I think that same dynamic is going to happen here in OpenSearch. So I want to thank all of you, particularly the maintainers of OpenSearch. I think you're the most important people in the project. That's why I fly to anywhere in the world to sit down and meet with you and ask you how our organization can support this project. And I want to thank the sponsors of the OpenSearch Foundation for all of their wonderful support. We're just getting started. We're in the first 5 minutes of a long game, and we're here to help. Thank you so much.
Thank you. All right. Thank you so much, Jim, for spending time with us today to talk about OpenSearch's great future with the Linux Foundation. We are super, super happy to be joining forces with the Linux Foundation and moving forward together. We also owe a big thanks to our great user community for all of the help along the way. Now let's build some proof into that statement. So if you've ever filed an issue, submitted a PR, commented anywhere in GitHub, given a presentation about OpenSearch, maybe you made comments in an RFC, or you participated in a community or triage meeting, or helped answer a question for OpenSearch on the forums, on Slack, or elsewhere, please stand up. Awesome. So now I'd like for us all to give each other a huge hand for supporting this project. Now that's what I'm talking about. Credit where credit is due. Congratulations to all of you. I want to thank you all so much for coming today. We've got a great set of speakers lined up. We really hope you enjoy the conference. Thank you.